question 3 is quite a long question. There's actually 3 parts to it. Let's do them one by one. First part asks us to find the coordinates, so coordinates, of the point on this curve at which the tangent is parallel to this line. Okay, so firstly, what does it mean to be parallel? Well, it means that it has the same gradient, right? So, the tangent, we're asked to find the point at which the tangent has the same gradient as this line here. But the gradient of the tangent is the same thing as the gradient of my curve, which I can find through finding the derivative, or dy by dx. So what are the two things I need to know to find this? I need to know where this is, need to know how to differentiate this, find its derivative, and I also need to know the gradient at this point. So if I take this, the second one first, so let's take a look at this one first, right? 4x minus 2y minus 7 equals to 0. Can I rearrange this? Yes, I can. This is the same thing as 2y is equal to 4x minus 7, or y is equal to 2x minus 3.5. So the gradient here, the gradient is equal to 2. So I want to find where the derivative of this curve is equal to 2. So let's differentiate. Let's find dy by dx, this one now. dy by dx is equal to, well actually no, let's not find dy by dx, dx first. Let's instead rewrite y. I've got a bit of space up here now thanks to that. So let's write this as y is equal to e to the, and if we expand this, what do we get? We get x squared minus x minus 6, and then negative 3 down the bottom. So this one I can differentiate. So dy by dx, if I go back to my other colour, dy by dx is equal to what? Well, I differentiate the whole thing with respect to the stuff up the top, so I get e to the x squared minus x minus 6, and to that I've got to multiply the derivative with respect to x of this stuff. So that's 2x minus 1, and then the minus 3, because it's constant, it becomes minus 0 and disappears. So, we've got to find the point where this derivative equals to 2. Why 2, you ask? Because of this over here. So we've got to find where 2 equals to e to the x squared minus x minus 6 all times 2x minus 1. So if you can remember that for a moment, what are we going to do? We're going to enter this into our graphic calculator, or for me, GeoGebra. So my first one is going to be y equals to 2, and this is my first curve, horizontally across the screen. Let me make it a little bigger for you guys. Style, make it size 5. Okay, now you can see it. My other curve, if you recall, was e to the x squared minus x minus 6 all times 2x minus 1. So y equals to e to the power of x squared minus x minus 6 all times 2x minus 1. It looks something like this. So again, let me make this a little clearer for you guys. What am I looking for? I'm looking for the point where these two intersect. So in fact, this point here, and if I double click on it, we find that this is actually at x equals to 2.83 and y equals to 2. So the values that we're looking for, the solution to this equation rather, is x is equal to, let's do it to a few sig fig, 2.82513. So 2.82513, which is approximately equal to 2.8323 SF. So the coordinates of the point at which the tangent is parallel to the line. Well, we haven't actually finished yet, right? We have to take this x value and substitute it back in up here. So we've got to get y equals 2, and then, again, just take this number and substitute it in into this expression up here on your graphing calculator. So again, I'm going to do this using GeoGebra. I'm just going to take this and copy it, and then I'm going to enter some new value. So let's say a, sorry, I'm going to need my algebra window open for a second. So good thing I didn't use a, because a is used up here. So b equals 2, and then I'm just going to type in the equation for my curve, which is e to the power of, and then I'm just going to, to the power of, and then I'm just going to enter in my value. Oh no, it didn't give me the right one, did it? Anyway, I had it anyway. It's 2.82513, right? 2.82513, yep. Minus 3. Yep. 2.82513 plus 2. Close that bracket, and then minus 3. So I think I've missed a bracket here at the front. Should be a bracket there. If I push enter, I get b is equal to negative 2.573 SF. So we come back here. Y is equal to negative 2.573 SF. So therefore, my coordinate is 2.83 negative 2.57. Okay, good. Well, what about the next part? Hence, so from what we've already done, we have to find the equation of the tangent and the normal at that point. Well, we already know, right, what the gradient at this point is. The gradient here is going to be 2. We found this out in the first part. So, we've got this point, y, we've got this, the point 2.83, negative 2.57, and we're asked to find the gradient when we, the tangent when we know m is equal to 2. The gradient is 2. So y minus y1 is equal to mx minus x1. What do we get? We get y plus 2.57 is equal to 2 times x minus 2.83. You guys obviously would be using unrounded numbers, but because I don't have the aid of a calculator with me, what am I going to get? I'm going to get y is equal to 2x minus 2 times 2.83 minus 2.57. Well, I need my calculator here. So c is equal to 2 times negative 2.83 minus 2.57. What do I get? C is equal to negative 8.23, so minus 8.23. So this is the equation of my tangent. In fact, I see, just checking the answers, that this shouldn't be a 3. This is a rounding error. This should be a 2, to be perfectly correct. So this is my tangent. To find the normal, I do a very similar procedure. I'm asked to find the normal next, right? Find the equation of the tangent and the normal at that point. So how do I find the equation of the normal? Same thing, except now the gradient of the normal is equal to negative 1 over the gradient of the tangent. So it's going to be negative 1 over 2. So same thing, y minus, plus 2.57 is equal to negative 1 over 2 x minus 2.83. And when we rearrange, what do we get? We get y is equal to negative a half x. I think it's going to be, what's it going to be? It will be minus 1.16. And this is my normal. Last thing. So this is the hence. Done this part? Done this part? Good. Find the stationary points of the curve and determine their nature. Okay, now we get kind of tricky. So let's go back here. New. What was our curve initially? It was y is equal to e to the x minus 3 x plus 2 all minus 3. And we're asked to find the stationary points. So you know at the stationary points, dy by dx has to equal 0. So we use our hard work from earlier on, where we found out that dy by dx is equal to this mess here. So we just copy that down. Dy by dx equals to e to the x minus 3 x plus 2 times 2x minus 1. And we set this equal to 0. Well, how do we solve this equation? Well, look at this part here. This is always going to be e to some number, right? Don't know what it is, don't really care, because I can know e to any number is strictly greater than 0. So I'm not going to get any solution here. Instead, I can safely divide by this and say that 2x minus 1 equals to 0. So x is equal to a half. So at x equals to a half, we've got a stationary point. Excellent, but what kind of stationary point is it? So let's draw a little sketch here. We've got a half here, and we've got our point here. Now, when x is less than a half, right? So this is a half minus, slightly less than a half, what happens? Well, if x is less than a half, then this number here is going to be negative, and this number at the front is always positive. So I can say my dy by dx will be less than 0, and negative times a positive will give me a negative. So the gradient is negative at this point, which means it's coming down as such. We know it's 0 at x equals to half, so what happens at slightly more than a half? Well, if x is more than a half, then this expression is positive, and this expression is positive. So my dy by dx is also going to be positive, and so the curve is going to go upwards. So what type of point is this? This is a minimum point. So what can we do? Well, what exactly were we asked to do? We check. We're asked to find the stationary points. So let's also find quickly the y value, because we shouldn't leave that unchecked. So y is equal to e to the a half minus 3 a half plus 2 all minus 3, which gives us, after some simplification, not much simplification unfortunately, e to the negative 25 over 4 minus 3. So we can therefore say, therefore, the point 1/2 e to the negative 25 over 4 minus 3 is a minimum. And we have finished.